Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 1 from section 7-3 in the SavvasRealize Algebra 2 textbook. The goal of today's video, I didn't even cut and paste, shame on me, but it is to use reference triangles to evaluate the sine and the cosine. Let's put that back in there. Alrighty. So what they're talking about here is they're talking about using the unit circle in order for us to find the sine and the cosine. So one thing to remember is that the sine is equal to the y value when we write the ordered pair out, and the cosine is equal to the x value. So if you have a convenient little unit circle handy, you could just take a look-see, and the x part of each coordinate pair is your cosine, and the y value is your sine. That being said, I'm going to show you how to do it with special right triangles in case you're in a pinch like I am and you don't necessarily have the unit circle memorized. Gio's is quite excited about this. Alright, so our reference angle here, it says 2 pi over 3. So remember, the top half of a unit circle is 1 pi. Alright, so there is 1 pi. So if I'm finding 2/3 of a pi, I would be taking that top part of the empanada and cutting it into 3 pieces. Now if I'm thinking about this in terms of degrees, right, and I'm cutting this top part into thirds, each of these would be 60 degrees. Okay? So if I want 2/3, I'm taking 2 slices here, which means that this angle, if I'm looking for degree measurement, it means that this angle is 120 degrees. Okay, so that's kind of the name of the game. I'm going to put the 120 here. So now we need to find our x and y, because again, the x is the cosine and your y is your sine. Now the biggest thing to note here is the 60-degree reference angle that I'm going to color red. Because if I were to drop down a line perpendicular to the x-axis, I could then go through and find the x value and the y value, right? Now remember, on these angles, because this is a part of the unit circle, I know that my hypotenuse is equal to 1. So if I go to my 30, 60, 90 right triangle, I can now set 1 equal to 2x on here. Alright, so that means that if I divide by 2, my short side of my triangle, which happens to be my x value, is 1/2. Right? Because that short leg is half of the length of this hypotenuse. Now this long leg, which is opposite to the 60, that is equal to the short leg times the square root of 3. So 1/2 times the square root of 3 is root 3 over 2. Alright, so my sine of 2 pi over 3 is equal to my y value, which is root 3 over 2, and my cosine of 2 pi over 3 is equal to my x value. Now notice this is going backwards on the x-axis, so this is going to be a negative 1/2, even though I was finding the length of a side, okay? But it's orienting the direction on the unit circle. So my cosine is negative 1/2 to show that I went to the left on the unit circle to get the 120 degrees. Alright, let's try that again. So now we're going to be dealing with a negative 45-degree angle measurement. So remember, with the negative 45-degree angle measurement, what I'm doing is I'm going clockwise on the unit circle. Okay, so here's my initial side, and I'm going to go clockwise 45 degrees for my terminal side. Alright, so this angle right here is negative 45 degrees. And here is the xy they're looking for. Now note, this is in quadrant 4. So my x value is going to be positive. So my cosine will be positive. And my y value will be negative because it went down. All right? So what I'm going to do is I'm going to drop a perpendicular line to my x-axis. And here I have a 45, 45, 90 right triangle. So what I can do is I could say, well, my hypotenuse is 1. So I can set that hypotenuse of 1 equal to my hypotenuse of my base triangle, which is x root 2. Then to get x alone, I'm dividing both sides by root 2. So I get that 1 over the square root of 2 is equal to x. But we don't like a radical in the denominator here, right? So we have to rationalize it. That means that I'm going to multiply this times the number 1. That causes that radical to cancel out in the bottom. So I'm going to call that 1 root 2 over root 2. So at the top, 1 times root 2 is root 2. And root 2 times itself is just a 2. So my x value, so right here along the axis, is root 2 over 2. Now my y value, because this is a 45, 45, 90 right triangle, my legs have the same length. So my y value is also root 2 over root 2. But remember, it's going down relative to our axes, so that one's a negative. All right, so the sine of negative 45 degrees is the y value, so negative root 2 over 2. And my cosine of negative 45 degrees is the x value, so positive root 2 over 2. Alrighty, so now let's try it for a and b here. So again, I'm just drawing in my unit circles. I'm going to do 2 of them right away just to save myself a little bit of time. Now these two look kind of similar, right? Because they both are dealing with 4s and 3s. Okay, so just remember your fraction rules. 4 over 3 is bigger than 1, and 3 over 4 is about 3/4, right? I didn't draw my line so good here, so we're going to fix that. Struggle's real today, y'all. We'll call that good enough, and just use your imagination that I know how to draw. Okay, I could probably bring that in. That's better. Alrighty. So, 4 pi over 3. Okay, we know that we're starting at our initial side here. That's how we always start, right? So 4/3 is bigger than 1. Okay, so I know that I'm going to be dealing with this entire top empanada because this is 1 pi. That covers 3/3 of it. So what I need is I need another 1/3 of my pi because this is 3/3 pi. So I'm going to take this bottom empanada and I'm going to cut it into thirds. Now remember that bottom empanada is 180 degrees, right? So each of these is 60 degrees, if that helps you to kind of orient yourself. Okay? And so right here is 4/3 pi. So this is my reference angle. Okay, so I'm just going to erase the extra parts of the pie that we don't need. Num 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 num. I'm sure they're quite delicious. So there we are. So I have a reference angle of 60 in here, right? Like I can draw a slightly larger triangle if I need it to make my life a little better. So here's 60 degrees. This here's 30. Here's our 90. So I know that this hypotenuse is 1. But if I'm using a 30, 60, 90, I know that that 1 is equal to 2 times the short leg. So my short leg here, which I happen to call x, is equal to 1/2 units. And then here, my long leg is the square root of 3 times that 1/2, so it's root 3 over 2. And because that long leg is kind of going down, it's going to be a negative root 3 over 2. Okay? Now, this is also going backwards, right? So this 1/2 is also a negative 1/2. Okay, so we just have to think about the directionality there. So my sine of 4 pi over 3 is equal to that y value. So it's equal to negative root 3 over 2. And my cosine of 4 pi over 3 is equal to my x value, which is negative 1/2. And remember, if you happen to have a unit circle available for you to use, you could find that on here, right? So I said that the reference angle here would be 60 degrees. So 180 plus 60 would put us at 240. We also have the 4 pi over 3 marked. My sine's that negative root 3 over 2. My cosine's that negative 1/2. So remember, you don't necessarily have to try to find these reference angles and stuff if you have a unit circle that your teacher lets you use. Okay? Alrighty, so now let's look at this one. So 3 pi over 4, that means that I'm taking a pi and cutting it into fourths. So I'm taking this top pi, cutting those halves into fourths. Okay? Now if I want 3/4 of that, here's 1/4, 2/4, 3/4. So here is my reference angle. Now, because I'm looking at fourths, right, I'm cutting each of these quarters in half, essentially. So here's 45 degrees for each slice. And so when I go to draw my reference triangle, which I'm using my special right triangles for, I'm dropping it down and getting a 45, 45, 90. So I'm going to actually draw that out here on the side so that we can have a little more writing space. I'm also wondering why I can't go further to the side here. I'm not that close. Oh, I guess I am that close. Okay. So our reference angle, right? 45, 45, 90. So remember, this is isosceles, so whatever my side lengths are, they're going to be the same thing. And the hypotenuse is that side length times the square root of 2. So because this is on a unit circle, we know that hypotenuse is 1. So if I'm solving for x, I'm going to divide by the square root of 2. So I'm getting that x equals 1 over the square root of 2. And we don't like that square root of 2 in the bottom there. That's a no-no. So I'm going to multiply this expression by the value of 1 that cancels that square root of 2 out. Because when you multiply by 1, you're not really doing anything to it, right? So 1 times the square root of 2 is the square root of 2. And root 2 times root 2 is 2. So this distance is root 2 over 2. And because it's coming backwards on the x-axis, it's going to be negative. And this y value is also going to be root 2 over 2. Because the x and y have to be the same. Now this one's a positive root 2 over 2 because we're going up on the x-axis, or on the y-axis. Alright, so if I go to write this out, the sine of 3 pi over 4 is that y value, so it's root 2 over 2. And my cosine of 3 pi over 4 is my x value, which is the negative root 2 over 2. So there we have it, guys. That's how to use reference triangles to evaluate the sine and the cosine. Until next time.